Hello and welcome to the first lesson of electronics. I am your teacher, Mr. Sitnick. That is Sytnick, and we are studying electronics. And for the bulk of this year, ladies and gentlemen, you are going to be working with something called an Arduino. Kind of looks like that. An Arduino is a kit. You have what we call if you look down here, you have the Arduino Starter Kit. That's what I've ordered for every one of you. Some of them might be used, and you can see I'm going to do an unboxing for you here. You can see what comes with it. The first thing you're going to know is it comes with a book, the Arduino Projects book, and it's got every single project that we're going to work on for the whole year. This book is going to be your year for the most part. Sometimes when they stapled these, some of the pages got mixed up or they're out of order. If you run into a problem with your book, it's not a big deal. Just message me or let me know in class and I'll get you a new book or I'll get you the right pages. We've got extra copies, we've got extra kits, we've got extra books, we've got extra parts. It's not a big deal. So if you actually bought a brand new Arduino Starter Kit, that's what you'd get. You'd get the booklet, you'd get all of your parts. You get your USB cable, you get your components, you get the breadboard, all the wires and fun stuff, an LED display, and a couple different motors. It's pretty neat. Now, what you'll actually be getting, most of you, is one that's already been kind of used because these have been used. And that means they might look a little different. You might have to fish around in the box for parts, but for the most part, everything's there, and if you can't find it, we can always get you extra parts. We've got lots of parts. So what you're going to get is more of something like this, right? You're going to have a box right here, kind of a paper box, and inside there'll be these papers that I use. Every once in a while, I'm going to make you take out all the parts in your Arduino kit and lay them out to make sure that you haven't lost anything. I'll also be doing graded checks to make sure you have all your parts. So you'll actually lay them out on physical pieces of paper, all your parts, and I'll do an inventory and see what you have and what's missing. And then you'll have all these kinds of fun things, and of course you'll have your Arduino board right here. So that's what you'll get. So for today, we've got a couple things. This is kind of the objectives, and I wrote it on a piece of paper for a tech class. You're going to watch the video. You're going to get a kit from me in the next day or so. I'm going to come around and make sure you got a kit. You got all the basic parts. You're going to read from Project 0 to Project 2. So let's just look at the booklet when you get there. You're going to start right here. Right there. It's only a couple pages in. You're going to read that. You're going to read here. You're going to look at all of these. You're going to read about the parts, about the board, and then there's a part about building the board. You don't really need to focus on reading that too much. You're not going to have to build a board. If you do, we'll do it together. I'll help you. We'll glue it up. We'll screw it in really nice. It'll be great. And then you'll have to, obviously, you don't need to do this setting up the Mac and Windows thing because we'll have that a little bit differently. We're using ours on Chromebook, so it's a little bit different. I'll have the next lesson in lesson 2 in the introduction. I'll show you how to do that. So you don't have to do that part. But then you got to get to know your tools. You got to read this section. You got to read this. I wouldn't stress too much about this section right here where it's talking about Ohm's law and resistance. But this part here, what is a breadboard? If this part's confusing, that's okay. Don't be too stressed about that. But be more interested in how the breadboard is wired. Read about this. Learn about your first components. You keep reading. And then eventually we're going to get you to build some circuits. That'll be kind of where we go with the next lesson. But you're going to read all of this anyway, up until Project 2. So that's the next thing. So watch the vid, get the kits from me, make sure the parts are there. You're going to read the booklet, and then you're going to do questions and definitions, and you're going to submit them on Google Classroom. You're going to submit questions and definitions. And what I mean by that is I'm going to give you this paper here. It's going to look something very close to this, and you're going to have to do the definitions of all of these parts, looking back and forth in those pages that I told you. And then when I say questions, what I want you to do is to write 5 questions with answers. So if you were a teacher, what kind of questions would you make? Actually, you know what? Let's make that 3. 3 questions with answers. If you're really having a hard time coming up with something different than what I wrote here with the definitions, then you could actually ask me 3 questions, like personally, like, hey, Mr. Sitnick, I'm not sure about this. What are we doing with this? Or you could actually ask me 3 questions and I can look at them and I could share them with you. I can answer them for you. We could talk about them as a class and those kinds of things. But your real goal is to get these definitions done and then to look at the pages that I told you to read and make up 3 questions with answers. And you can do that on the back side of your paper if you want, right? You can just use the back side. How will you submit that? You'll obviously take a picture of your work. That's how we're going to submit most things for the time being. You're going to take a picture of your work and just submit it to that lesson or that assignment on Google Classroom. Pretty easy stuff. So with that being said, you know your goals now. So I want to kind of go through some of the book with you though. We've got a couple minutes here, so no big rush. So you're going to watch the vid, get the kits, read that, do the questions, and then submit it on Google Classroom. I'll bring that back at the end of the lesson so you can see. But now let's take a look at this book, and I'm just going to kind of go over some of the important stuff that you need to know, some of the stuff that I think you should focus on, and maybe some of the stuff I say don't worry so much about that right now. Worry about it later, but you're going to have to do most of this reading on your own, and this is going to take, I'm going to give you a couple days to do this. One thing I will say is in this class, always bring something to work on, bring something to read, bring something to do to stay busy because it is a project-based course and I cannot move on. I cannot give you extra work in a shop until everybody is done, right? So always have something to do, and there might be some times if you're a fast worker, you're going to learn that very quickly. You're going to be sitting around. So if you are a fast worker, the first thing I would say is really take your time and do a very neat, clean job. It'll keep you busy and it'll also enhance your learning and it'll be much more satisfying. So always work slow, take your time, and I have to make sure everybody's done so you're going to have lots of time. So always bring something in this class in case there's a little bit of extra time. One thing I have encouraged people to do in previous times is to get their own Arduino Starter Kit or get an extra one from me and build their own projects on the side for fun. If you're getting advanced and you're into it, we could do that too. So I'm going to just kind of start here. We will go and look at some of this. So we'll look down here. You could read this. Basically what they're saying here is that this is a microcontroller, and you can read what that means, how these things are used in almost everything we use daily, right? All kinds of things. It tells you what a sensor does, how a sensor senses things, an actuator makes things happen, an actuator makes light go on, it makes an engine turn, it produces heat, it makes motors spin, things like that, right? Actuators are taking electrical energy and making physical things out of them. Light, heat, motion, sound, those are actuators. The parts that you put on a breadboard that do those things are called the actuators. Sensors, and then microcontrollers listen to sensors and they talk to actuators. You'll have to read through that. Don't be too stressed about it, but get a general view of the language you're using. This is not a basic course. This is not an easy course. It's pretty complex, and you have to have a liking for this kind of thing to kind of get the language, get the lingo, especially when we get into coding. Coding is coming up next. The first project we're doing in the next lesson, there's no coding. You're just doing some wiring, making some things light up, easy peasy. But after that, we get into writing code for these boards. So not only will we wire these boards, you can see right here, actually, like I made a project right here. I wired up a board and I can push the thing and it'll light up after, once I plug it in. But after, we'll build things like this and we'll write code to these microcontrollers. And the code will also tell the board what to do. It's pretty neat. That's like a whole language. So you will be learning coding in this class, as well as the basics of electronics components and building and wiring circuits. We can flip ahead. Now this, as every project goes on right here, you're actually going to kind of like, so if your project uses LEDs and wires and resistors, that's when we'll kind of talk about what they are in detail. In the first lesson, I don't expect you to memorize all of these, right? I don't expect you to know all these parts, but you've got to read them all. You got to get comfortable with these kinds of things. You've got to start to be like, oh, I've heard that word. I kind of know what that does. Because when you get to a project that uses some of these things, you're going to know what they do by the end of that project. So right now, get comfortable. Learn the language. Learn the vocabulary. Start thinking in terms of electronics. So read these, and then obviously the first projects we use are going to use some of these parts, and that's where you're going to get to know them. So you might not need to know what a potentiometer is or a servo motor just yet, but there will be projects where you use those, and boy, oh boy, by the end of those projects, you're going to know what they mean. So don't get overwhelmed by this. Don't get flustered, but I want you to read through all this. And at any time when you're watching this video lesson, you can obviously pause it and follow along with me. You can have your book with you right now. So I don't suggest you watch the video in isolation and then go do the reading. Use me as I kind of flip through this. Take your time, pause the video where you want, and get a real thorough understanding. You're going to have lots of time to do this, so take your time and kind of get to know what they are. And then this section here is the schematic symbols for those parts. And you only need to know those when you're making schematic diagrams like this. But as every project goes on, you're going to need to know what more and more of these are. And when I ask you for what the symbol of something means, you need to know what these schematic symbols are. It'll make more sense once you see it in the next bit. We're going to talk about the Arduino board here, right? This is the Arduino board. One thing I will say, right here, this breadboard, the Arduino, when it's empty, when you plug in your power supply, right there, you can also plug in an actual power supply, but we always use USB power. This, you can plug it in and take it out, but eventually it's not going to wear out, but it's going to wobble the screws at the back of your board, and you might need a screwdriver to tighten them. You might need to hold the bolt at the back. Your bolt might fall out. Also, these little pegs might get loose, so if they're getting loose on you, we can glue those in for you. Just ask for glue or bolts. I've got extra bolts and extra screws if you ever need. If you lose some, just to make it secure. What I always do is I leave this in once I put it in. If I put this in for a project, I'll do the whole project. I won't unplug it here and plug it back in. The more times you do that, the more problems you're going to have with this board becoming loose. It's still going to work, but it's really annoying working on a board that's a little bit loose. So don't plug this in unless you're ready to go, unless you're ready to test things. All right. Now, you can look at the board and you're going to read about what these parts do, read about what they're useful for, and I can't sit here and read all of this for you. I'm not going to make quizzes for you. I'm not going to make a bunch of questions on every page of this book. That you need to do the work. This is an elective course. You have chosen to be here. So I expect a certain level of engagement from you. You need to know what the USB port does, how to reset something, what those buttons mean, what the TX and RX mean, what the digital pins do, right? And things like that. You can skip this section now here. You don't need to build the breadboard. I've already done that. And the next thing you know, like, yes, if you're doing it at home and for some reason we switch to homeschooling or things like that, or you take a project home to work on, you could download the Arduino app. It'll look, actually, let's see if I have it on this computer right now. Yes. It'll look something like that when you download it. And it'll have a place where you can write your code, and you'll take your board home and you'll write your code and upload it through the USB cable. But for most of you, we're going to do it on Chromebooks, and we have a whole different way of doing it. It's pretty much the same, but you don't have to do the installation. If we're ever in the lab, all of the computers in the lab already have this installed on it, so that's pretty cool too. So don't worry about that. So look at a couple pages you get to skip. Next up, getting to know your tools. You're going to have to know what a transducer is, a sensor, actuator, and a circuit. Don't worry about this part down here, but read this. You need to know a couple things right now, though. You've got a section of the board that's a ground, that's the negative, and you've got the 5 volt, which is the positive. And as you'll see, almost every project you ever do, you're going to run the power, you can see here, to the 5 volt, and you can read it on the side there, it says 5 volt. And then you're going to run the negative to the one called ground. And every project's going to use that. And you can use any wire. You can use these fancy jumper wires like this if you want. That's what I'd recommend, but honestly, any wire will work in the end. So you need to know that this is the positive. It flows down a strip. You can connect to the positive, send it to the board, and then send it back out to the negative to make a complete circuit. So you can kind of look at this. So you got your questions here. Don't worry about this page, but obviously read it. you need to know this thing about a circuit, and then talking about what a breadboard is, and reading about your first circuit, reading about the parts in your circuit. You'll have to read about this. You'll have to read about a series and a parallel circuit, and that's what you'll have to do. So now I'm going to spend some time going in a little more depth about what the breadboard here, like one of these things, right? What a breadboard is, and how these circuits that you're going to do work. So for the next few minutes here, we've got a couple minutes left, I'm going to just kind of quickly go through this. So what you'll see is that when you connect, let's use, an X-Acto. You'll connect your wire to the positive side, and this whole strip here is positive, you can see. So this whole section right here is all positive. So if you run a wire from the positive to here, this now has positive. So you can run a wire out to a positive, to a negative, and then back to the negative side, which would obviously connect to ground. Look at how everything's wired. This is a positive strip, this is a negative strip, and these are all connected under the breadboard, right? So there's a question coming up that says, how is a breadboard wired, and things like that. So that's the first thing you need to know, is this whole strip down here, if you're looking at an unwired breadboard, right? This whole section, everything on here is positive. So you can wire out of here to a strip to make this whole strip positive, or this whole strip positive, or that. But if you wire to this strip, that strip's still by itself, right? And then this whole side is negative. So whatever you build your circuits, you're always going to send it on the way out to a negative. So you'll have a positive side, you'll run things out, and then you'll do fancy stuff in here with wiring, and then eventually at the end of your circuit, you'll always send it back to negative. Now there's a couple other things you can do, and this is cool. You have different pins here. You have all of these pins here you can see. And you could decide if this is going to be an output or a sensor or things like that. And that's later with the coding. So when we get to future projects, you can say, I want this slot here to be an output of 5 volts. Or I want this slot here to be an input. I want it to read if electricity gets to it. And if electricity does get to this pin, I want the board to do something. So that's the basics of it, right? You can have just plain simple circuits with no code, wiring them, going from positive, doing things, and then going back to negative. Or you can run that as well as having different sensors, inputs and outputs. And you've got a lot of them, right? You've got a lot of places here where you can turn things into being inputs or outputs, where they will either read if a signal is coming in or send 5 volts of power out. So there's different ways of looking at that. So that's the first thing you need to understand about how the breadboard is wired. Let's take a look at this circuit. This is a good one, actually, right? So look at this. The red is positive. Positive goes down. It's connected. So they ran a resistor here, right? One of these little guys right here, a resistor, which is the exact same as this resistor, even though they look different. We'll get into that later. There's different colors, doesn't matter. You can always read the code and find out what a resistor is. So it goes through the resistor to the light. And look at that light. Notice how there's like a bend in that? That's because wherever the bend is, if you look at any one of these LED lights, there's always a side that is longer. And we'll talk about that right here. But if it's longer, I would suggest you take a bend and make a bend like that so that it looks something like your diagram. So in this case, they put it in that way, right? Because the bend is there. So it goes from a resistor out of the positive to a resistor to an LED light, back out on the same strip. It connects to negative and then runs back to the ground. And look at this. This is a schematic. It's the same thing. 5 volts, there's your power. It runs through a resistor. Remember, you've got your symbols over here. That's the symbol for a resistor. So 5 volts means positive to a resistor to an LED. Remember, there is your symbol for an LED right there. And then it goes back to ground. So this right here, this schematic is using symbols and diagrams to represent something in the real world here, right? This board looks a little more complicated than this. This looks just easy, right? But they mean the same thing. This is how we would wire this schematic on our breadboard. Positive to a resistor to a light, Make sure that the bent side, the long side, is there, and then it goes there to negative, back up the negative strip to ground. That's kind of cool. That's the basics, and that's a schematic, and that's an actual diagram. So you can read what an LED is, and now in your diagrams or your definitions, you're going to need to know what an anode is and what a cathode is, I believe, right? So the longer side is called the anode. It connects to power. The shorter leg is cathode, and it'll connect to ground. So when you get your LED, like if I take one fresh out of the box here, take a look at this. There is no bend in that, even though in the diagram, there's a bend. So what I would suggest is when you get the longer side, right there, take it and put a bend right at the top. It'll also make those even so you can put them in the board easier. And then all you have to do is match the bend with the bend in the diagram. The diagram will always tell you. But the bent side should always connect to positive, and then the straight side should always lead towards the negative end of the chain in your circuit. Resistors. Whoa, resistors confuse people because in the classroom, look at this. You just get strings of resistors, or in your box, you might just have some clumps of resistors here, right? That's okay. Nothing wrong with that. You've just got to be comfortable. And every project, for the most part, you're always using the same resistor per project. So once someone finds out what the right resistor is, or you do the math, you can always say, okay, I need to use this resistor. But look at this. This is a 220 ohm resistor, and it matches nicely with that. But guess what? This is also a 220 ohm resistor. And boy, oh boy, sorry, it does not look like that. Keeps rolling away. But they're the same thing, because if you go to, and this is going to be like your kind of resistor holy grail right here, on my Canadian Tire tag, on page, what page is that? 41, right here. Look at this. This, when you say, I don't know what resistor to use, Mr. Sitnick, well, your kit might have blue resistors or brown resistors or both, but there's a code and there's a formula here to tell you how to calculate using the first digit, second digit, third digit, multiplier, and tolerance. So this is a code to tell you what resistance a resistor is. So here we go. Here's a 220 resistor, but that's also a 220 resistor. Here's a 560. So you're going to have to use this page very often. Page 41 in your book should be marked with a sticky note or something for the year, because you're going to always have to look back to your resistors. Always. And it gets confusing and it gets frustrating. And sometimes you won't have the right resistor. I got lots of resistors. I got boxes of them. I can get one from another kit. We can borrow you one. We got lots. Don't get stressed out. If you are wiring something and you are missing a part, tell me, obviously, but keep wiring. Keep doing everything else. Just go to the next part, wire everything in. We'll get you the part. Eventually, we'll put it in. It's going to be great. But you need to know on page 41, I would put a sticky note in there. So you've got your resistor, and that is going to resist the flow of electrical energy. You're going to have to read about that. It actually will produce a little bit of heat because it's taking a certain amount of power and lowering it down. Kind of how like these blocks that power your computer or your phone, how they get warm. It's kind of a similar concept. It's taking one kind of current and stepping it down into something that a phone or a computer can handle. And there's resistors within that, right? They're producing heat. A switch, well, I think you should know what a switch is. It looks like this. It looks like a little kind of spider or something. But a switch is just a button. They're a little annoying to put in the breadboard, but you can get it right. There's schematics for switches. That's an open switch versus open switch. And if you close that line, it'd be a closed switch. That's a push button switch, and that's a toggle switch. Toggle is like a light switch, and a push button is really what we're dealing with here, right? I would accept either of those if you drew me a switch. I'm not going to be picky about that right now. So you need to know those parts. They're going to be in your definitions. An anode and cathode is in your definitions. Here's an example of a circuit, I believe. Yes, so here's the first circuit you're going to have to build. We're not going to build that today. I want you to read the rest of it. I want you to understand the difference. Let's see where my paper was here. Excuse me. So you need to know what an LED, a resistor, a breadboard, a switch, anode, cathode, sensor, actuator, microcontroller, and parallel and series. And that is where these two circuits come in. And we'll talk about them a lot tomorrow. But in a series circuit, you're going to learn that there's only one way the electricity can flow. And in a parallel circuit, you're going to realize that there's many different ways the electricity can flow. And still, this circuit can work many ways. This circuit has to work only a certain way, right? So series circuit, one path for electricity to flow. Parallel circuit, many. Read it, use the definitions that you come up with from there. And then on the next lesson, we're going to actually build this, and this coming up next. And you're going to submit those. So once again, things to do, watch the vid, get the kits, check things are there, read the entire booklet. Maybe you've read along with me. And do questions and definition sheets. So put 3 questions on the back with answers, or 3 questions just to me, and then submit them for assignment 1A in the Google Classroom, so we can see that you're making sure you understand how to submit that in the future, because you're going to be doing a lot of that in this course. I hope I haven't talked too much gibberish. If things are overwhelming or there's a lot of information at the start, that's okay. Things will get kind of fun. And once we get into Project 2 and Project 3, you're going to be building circuits, writing code, making it work, learning some new parts, the end. So the beginning's a little intense, and all the words and definitions that you've kind of heard so far, you're going to be using those every day, and they're going to be like, you're going to know them like the back of your hand. It's going to be easy. So don't get too stressed out right now, but this is very much an independent study course. It's very much what you make of it. I can't help you with too much. You know, I can't rewire your board for you if you wire it wrong. You're going to have to figure out your problem. I can't rewrite your code for you if you get it wrong. You're going to have to figure out the problem. And like I said, this is a class where we're going to all have to get to points together. So if you're a fast worker, slow down, relax, bring something else to do. Maybe give advice to other people if you can, if there's something that maybe you can help them with. If somebody's having a problem, always talk to me about it, and keep busy, have fun, and we'll see you. Submit everything in. That's what you need to be doing right there. We'll see you soon, and we'll move on to lesson 1B, where we're going to submit pictures of all the circuits we build. And that'll take us a few days too. No rush. I hope you enjoyed, folks. Take care.